Okay, guys, today we're going to be continuing with our practice of trig functions on the unit circle, and we're going to be specifically looking at the properties of trig functions in each quadrant. So today's kind of an intro day, and we're going to be first breaking apart this coordinate plane that we start out with and figuring out which trig functions are positive in each quadrant. That will help us with our work for the next 2 days. So what I want you to start out doing is on this first coordinate plane here, I want you to draw a reference triangle in each quadrant. Don't worry about the reference angle, just worry about drawing your triangle. So what I mean is draw a triangle in the first quadrant, form with the x-axis, draw a triangle in the second quadrant, third, and fourth. The next thing I want you to do is maybe highlight your reference angle. So remember that reference angle is always the angle that is formed with the x-axis, so close to the origin. And I want you to also put on your labels for the sides of the triangle. So like this is the opposite side of our reference angle. This is the hypotenuse, and this is our adjacent. Let's go ahead and go around the entire circle and put all of those labels on. Remember, those are always in regards to the reference angle. Next thing I want you to do, what sign would that opposite, adjacent, or hypotenuse have given the quadrant it's in? So we know, first of all, that a hypotenuse is always what? Think in your head. This hypotenuse is always positive. So no matter what quadrant you're in, hypotenuse is always positive. We got lots of practice with that last week. The legs will have different signs depending upon what quadrant you're in. So if we go right from the x-axis, this adjacent side will be positive. This opposite side will be positive. Continuing on to the second quadrant, this opposite side is positive because you're going up, but this adjacent side is negative because we're going left on the x-axis. If we go down to the third quadrant, this opposite side, where you're going down, is negative. And in the fourth quadrant, this opposite side is also negative. Now we're going to use those signs and the labels that we've created to figure out which trig functions are positive or negative in each quadrant. So in this first quadrant, remember this is quadrant 1, let's talk about the signs that sine, cosine, and tangent would have here. In the first quadrant, if you took the opposite and put it over the hypotenuse, you'd have a positive over a positive, so sine would be positive. Cosine is the adjacent over the hypotenuse, again a positive over a positive number, so your sine would be positive. And tangent would of course be the opposite over the adjacent, so a positive over a positive again, meaning that the tangent would also be positive. We also know that the cosecant, secant, and cotangent would follow the signs of their reciprocal buddies, so they would all be positive. So key idea in quadrant number 1, all are positive. That's not going to happen every time, folks. Spoiler alert. Let's go over into the second quadrant. In the second quadrant, if we take a look at the sine, the cosine, and the tangent, the sine is going to be the opposite, which is a positive, over the hypotenuse, which is a positive. So no matter what the number is, it's going to end up being positive. Cosine, on the other hand, is going to be the adjacent, which is a negative in this case, over the hypotenuse. A negative divided by a positive will create a negative cosine value. The tangent is the opposite over the adjacent. A positive divided by a negative, positive divided by a negative will also create a negative. Now we know, we can write down those reciprocal values. They will follow the signs of their reciprocal buddies. So key idea that I want you to get in your head, the trig function that's positive in the second quadrant, so this is quadrant 2, is sine. You might want to put, and also cosecant, but main idea, sine is positive in the second quadrant. So everything's positive in first, sine is positive in second. Let's continue on into the third quadrant. In the third quadrant, the sine is the opposite, which is a negative, over the hypotenuse, which is a positive. A negative divided by a positive would give you a negative sine value. Cosine, similarly, the adjacent side is negative, hypotenuse is positive, so you have a negative divided by a positive, also would give you negative. The tangent, be careful here, is the opposite over the adjacent, a negative divided by a negative. If you take a negative divided by a negative number, like -4 divided by -2, it is of course going to make a positive number. The reciprocals will follow the signs of their reciprocal buddies. So, take a look here in the third quadrant. The tangent is the one that gets to be positive. And cotangent, but for the use of our acronym later on, I want you to cue in on the main trig function. So, just to review, all are positive in the first. Second quadrant, sine is positive. Third quadrant, tangent's positive. I bet you geniuses can figure out what's going to be positive in the fourth quadrant. Everyone's going to get a chance. So we have sine, cosine, tangent. Sine would be the opposite over the hypotenuse. So a negative divided by a positive, obviously negative. The cosine would be the adjacent, a positive, divided by the hypotenuse, a positive. Positive divided by a positive makes a positive value. And tangent, opposite over adjacent, would be a negative value divided by a positive value, so it would also be negative. We know the reciprocal buddies would follow suit. So, in the fourth quadrant, this is our fourth quadrant, our last one, we get a positive cosine. And secant. I'm going to zoom out, make sure you've gotten each of those pieces of information down, cueing into the fact that first quadrant, all are positive. Second quadrant, sine is positive. Third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. We're going to take that and put that information on the graph below. In the first quadrant, actually, let's label our quadrants real quick. 1, 2, 3, 4. By the way, I don't know why when we talk about quadrants, Roman numerals are always used, but they are. Okay, so in the first quadrant, I want you to put a big old A. Guess what that A stands for? It stands for all are positive. In the second quadrant, look back above, which trig function was positive? The sine, so put a big S. Third quadrant, look and see which trig function was positive? The tangent. And in the fourth quadrant, the cosine was positive. So again, these little letters stand for what is positive, which trig function is positive in that quadrant. A cute little acronym that helps us remember this is all students take calculus. All students take calculus. Little acronym that helps us remember each of the quadrants in order, which trig function is positive. So in the first quadrant, all are positive. In the second quadrant, sine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. Let's take that and use it to solve the problems below. Oh, just a smidgen of review. If you're not very good with your inequality signs, you're going to need to be. So please remember that this sign right here, see how it like looks like an L? That means less than. Looks like an L, so it's like less. And then this sign means greater than. You can turn it into a G. Watch this magic. Wow. Greater than. I know, you're probably amazed. Okay, so our job today, very basic. We are just figuring out which quadrant theta, our angle, lies in, is sitting in, given the inequalities that are shown below. Here's how I would start out. First of all, I would read these inequalities. So they're telling us that the cosine of theta is greater than 0. What they're telling us there is if it's greater than 0, then we have a positive cosine value. They're also telling us that sine of theta, if we took the sine of it, it would be less than 0. Less than 0 means that we would have a negative sign. I always start out, I draw a little coordinate plane, and I put my acronym in there. All students take calculus. And it's like a logic game from here. So take the first tidbit of information. We have a positive cosine. If we have a positive cosine, we should be able to eliminate two quadrants. Cosine is only positive in the all quadrant and in the cosine quadrant. So we know that theta cannot lie in the S or the T quadrant. Then we can move on and we can use the second tidbit of knowledge, that our sine is negative. So in between these two quadrants that remain, where is the sine going to have a negative value? Well, all are positive in the first, so it can't be negative there. We know that we must be in the fourth quadrant. So our final answer would be quadrant 4. We're not evaluating any trig today. We're just figuring out which quadrant theta would have to sit in. Let's try it again over to the right. First, break apart what this information means. Sine of theta is greater than 0. So that means that sine is positive. We don't know what tangent is, but they tell us that the tangent of theta is less than 0 in this case. So we have a negative tangent. Make your coordinate plane. Fill in your little acronym in order. All students take calculus, going in from quadrant 1 to quadrant 4. And then let's use our information. So the first thing they tell us is that sine is positive. That should allow us to eliminate 50% of the quadrants. So sine is always only positive in quadrant 1. And which other quadrant? Oh, the S quadrant. That stands for sine is positive. Sine is negative in these bottom two quadrants, so we cross them out. The next thing we know is that the tangent, oops, not highlighter, the tangent is negative. So in which of these two quadrants is tangent going to be negative? Well, it's positive in the first, so we have to kick that one out. It is negative in the second quadrant. So our correct answer there would be quadrant 2. Let's move along to the back and give some more a shot. In example number 3, you'll see that we're given two pieces of information again, and this time we're going to be dealing with one of our reciprocal values. So let's first talk about what this says. Tangent of theta is less than 0, so we know that tangent is negative. Then we're also told that cosecant is less than 0. If cosecant is less than 0, then its reciprocal is also less than 0, sine. So if sine is less than 0, that means we have a negative sign. So just a review there, if the reciprocal is negative, well, its reciprocal buddy is also negative. So cosecant goes with sine, cosecant's negative, sine is negative. Let's draw our coordinate plane and start knocking out quadrants based upon the information given. Tangent is negative. That's going to allow us to knock out 50% of the quadrants. Tangent is only negative in quadrants 2 and in quadrant 4. It's positive where it says all, and it's positive where it says T, so we have to kick those out. Between those two that remain, we want to find the quadrant where sine is also negative. Well, sine is positive where the S is, so that one's kicked out. We know that we have to be in quadrant 4. Let's deal with another reciprocal value to the right over here. We're first told that tangent's positive. We're next told that secant is less than 0. If secant is less than 0, then cosine is also less than 0. So we know that we have a negative cosine. If we have a positive tangent, kick out the two quadrants where tangent is not positive. That's the S quadrant, quadrant 2, and the C quadrant. All of them are positive in quadrant 1, and tangent is positive in quadrant 3. Last but not least, in which of these quadrants do we have a negative cosine? That would be in quadrant 3, because cosine is positive in quadrant 1. Let's move on to this next row. I want you all to pause the screen and give each of these a shot. 5 and 6. Check out your work for number 5. You should have had that tangent was positive based on this inequality. Cosecant was positive, which meant sine was positive. Tangent and sine are both positive in the first quadrant. If secant is less than 0, that means cosine is less than 0, so we should have a negative cosine. If cotangent is less than 0, that means tangent is also less than 0, so we have a negative tangent. And this one, the first piece of information that we're given, negative cosine, you should kick out A and C. Negative tangent, you should kick out the T. You should have gotten quadrant 2 there. This last one, we're going to try to figure out where the angle is going to be, and it's going to look a little different. First of all, they tell us that tangent is undefined. Tangent is only going to be undefined on an axis. It's never undefined on a triangle. So think about your ordered pairs on these axes. Remember, that's how we have to figure out the sine and the cosine value on an axis. That's the only places where tangent can possibly be undefined. You'll remember that tangent is the sine divided by the cosine, or the y divided by the x. So let's go around and find what tangent would be at each of these locations. Sine, 0, divided by 1 would give us 0, this location. So it can't be there. Sine, 1, divided by 0, cosine, would give us undefined at this location. So it could be there. At 180 degrees, sine, 0, divided by negative 1, cosine, would give us 0. So it cannot be there. And last but not least, down here, negative 1 divided by 0, your sine divided by your cosine would give you undefined. So we're either up here or down here. But the last piece of information they tell us is that sine is greater than 0. If sine is greater than 0, that means we have a positive sign. At which of these locations is sine positive? Well, that one value. So we should be able to say that theta equals 90 degrees, or pi over 2. It's not in a quadrant there, it's on an axis. Again, that is all because your tangent is undefined. Only place where tangent is going to be undefined or cotangent is on an axis. Let's go pause the screen and give this one a shot. You could have used the graph from the one that we just did to remember that tangent is equal to 0 at either 0, 360, or 180 degrees. Let's use this last piece of information. Cosine is less than 0 to figure out where theta is. If cosine is less than 0, that means we have a negative cosine. Well, if this is our cosine value, at which location is it negative? That would be over here. So we can say that theta equals pi, which is the same thing as 180 degrees. Woohoo! Those were some fun additional ones. Remember to log back into office hours if you have questions on either of these types of problems. and give your homework a shot. Woohoo!